it's not an easy question for me to answer because I've been working on in many different areas, in RNA enzymology, in splicing, in transcription, and also small RNAs. And so if you don't mind, because I will really have a difficulty in choosing just one. So I will give you a very brief information about 3 different discoveries in different fields. One was still relatively early from the 1980s, where we were discovering RNA ligases involved in ligation of RNA in eukaryotes. And this was very interesting work because we describe a new type of phosphodiester bond, which results, from the ligation. And later, we started doing this in plants, but then we extended this to mammalian cells, and both pathways actually operate during tRNA splicing in a kingdom-specific way. So one pathway in plants and yeast, another pathway in mammals. So that's one thing. Then I originally was working, so that the work which I told you about was actually done in Poland because my background is Polish. I moved to Switzerland only about 34 years ago. And then when I moved here, I actually started to work on transcription. One of the very unexpected, totally really not expected discovery was a very close relationship in plants between POL2 and POL3 promoters. So the only distinction between POL3 and POL2 promoter is one helical turn difference in a space between 2 identical elements. So when you insert one helical turn, you change the specificity from POL2 to POL3 and vice versa. And we actually could demonstrate that this happened during evolution. And U3 snRNA gene, which is involved in ribosomal RNA processing, is POL2 in mammals, but it's POL3 in plants. And we can change this specificity. So now I'm getting to the last one, was the most recent example. And one of the most important decision in my life was to switch to work on RNA interference and microRNAs. And I did it about 20 years ago. And we really came up with many important discoveries about the mechanism how dicer is cleaving double-stranded RNA. Also, what is the mechanism of translational repression? And also we have discovered in brain, microRNAs turn over much, much faster than in other tissue. And all these discoveries were kind of accidental, but I always like these accidental discoveries because if you are kind of prepared what you will discover, or you want to discover something specific, you don't come across something of really interesting. So that's my answer, complicated. I think this is very important to somehow follow, the intuition or the serendipity, because otherwise, if you are sticking to one area, you may miss a lot of things. It is very important that science you find the most exciting. It's a mission, it's a hobby. I always argued that, I'm really doing my hobby work and I'm in addition getting paid for that. I mean, the fantastic arrangement. There are 2 kinds of scientists. The scientists who stick their whole scientific life to a single protein or single enzyme. And they go deeper and deeper and they understand the mechanism and individual amino acids, what they do. I couldn't work. I'm usually getting bored after 5-10 years with something which I'm studying for too long. And I also find a very big pleasure in reading about a new area, because you have really original view of this area. People who work on a certain topic for too long, they don't appreciate. Some people consider that changing the topic too often is bad for you, because you never get famous. Your name is not associated with a specific reaction or specific product. But I couldn't care less about that. I want to be excited myself. You should follow your nose, your intuition, and have courage to change the subject from time to time. When the scientists go through, they go through the studies, they go to master work, they go to PhD, then they do postdoc. At these stages, they should try to actually study different things. Maybe when you go for a postdoc or a second postdoc, you should think ahead of time, but maybe this would be a good area I want to stay in, and I'm going to the lab where I can learn basics in this field, and I can also have somebody who will support me in the future. If you work with a famous scientist, usually you get support from these people, and this is very important. This is very important. Generally, one should not go for numbers. One should go for quality. But one should understand that when you have a PhD student who has to graduate in 3 years, or even in 4 years, so you have to plan things in such a way that he will close up the story he's working on. But generally, I would insist that one should compromise between, quality and publication. One should try to make the work of the best possible quality, and such a work, it stays in the field forever, in a way. And in particular now, with so many papers being published, papers, we just add small things to the story. They are quickly forgotten. So I was always in favor of going for a big story, but sometimes this was not appreciated by my colleagues. Yes, my students or postdocs, because they wanted to have a paper. So you have to find the right balance. This is extremely important. And I have my own experience here because, I left Poland when I was already 42, and Poland was still a communist country at the time, where we had no freedom to travel. We were getting very poor funding, and we had no community of good people around with whom we could collaborate and work. I still need to add that, Poland was quite exceptional communist country because we were relatively open country. Even during communist time, I could go for a postdoc to United States. I could go for a sabbatical to United States. This was possible. I could even take my family with me. So it would be impossible to do this in Czech Republic or in Bulgaria, in Romania. But in Poland, it was possible. Maybe because Poles were always revolted. There were uprisings, there were fights, and they were letting the steam go. Okay, go. Better you stay in the States and don't cause trouble here. So I then appreciated these fantastic working conditions in the States. And in America, there is this very special attitude towards science. They are extremely competitive. And I happened to work with two very famous bosses in the States during my postdoc and sabbatical, with Severo Ochoa, who was one of the persons behind the genetic code, and Aaron Shapkin, who discovered 7-methyl G coupling of mRNA. And I was there at the time when this discovery was made. So I really could see this top science being done in front of my eyes. And this stays with you forever. And you learn how important it is to really get committed to science. And I saw those people working day and night. And I was also working day and night, especially that we were coming from Poland for a defined period of time. So I came originally for 1 year. I could extend it for seconds. So I had to work really day and night. My wife tells me this, even now, you were not taking care of your kids, but working. This environment, in particular in the United States, and maybe 40 years ago, when I was young and I was doing my postdoc sabbatical, America was still probably at a bigger distance from European science. Now, European science is of fantastic quality. So there are labs in the UK, in Germany, in Italy, in France, where people actually, they don't need to go to the United States. But I always advise go to the United States because the attitude there and competitiveness is different. People are so driven to deliver. Yeah, which is good. Because I always think that scientists should work under pressure. I'm against giving a scientist a lot of money and then you do what you want. You should be under pressure to publish, to collaborate with others, write grant, because otherwise you may lose contact with the reality. The answer is very obvious. And I think the recent situation with vaccines developed against COVID virus, and people are not aware that behind these vaccines, there are generations of research. People, were doing research, getting to this level that one could develop this thing. And if you take any recent issue of Cell or Nature, Science, you see this incredible progress. Part of this is driven by technology. You have genomes of so many organisms sequenced. You can do genome-wide association studies and identified bases of diseases which were absolutely abstract before. So I think that to me, this is obvious that the contribution of science to our well-being, to the community, to the progress is just immense. The problem is that not everybody is appreciating that. And there is this opposition against science, which to me, to the scientists, is totally illogical, that people do not understand how much they benefit from science. But unfortunately, here are all those fake news, internet, the rightist movement, which are, negating even existence of a COVID virus or HIV virus. And sometimes those are even scientists. So I think it's a very important mission for scientists not to stay closed in your laboratory, but go out, write popular articles. And, in Switzerland, there were 2 referenda. Switzerland has this institution of referendum, that if 100,000 of people submit a proposal that we want to stop working on genetically modified organisms, any organ, then this goes to the vote, and people are voting. Fortunately, people are usually smart. They understand what it would be if one would forbid working with mouse model of disease or research on transgenic plants, which may solve the problem of nutrition in the future. I think this commitment of scientists to popularize science, often write book, write popular article, which are destination of which is just to lay people, because science is so complicated these days. So lay people are often confused. So you have to put an effort to explain these things.